Hi guys, today I would like to explain to all of you about the solution for one case study about the back absorption column. Okay, so let's start. First of all, we can get the information from the question. That is cross-sectional area, that is 0.186 meters squared, temperature at 293 K, and the pressure 101.32 kilopascal. The inlet air contains 2.6 mol% acetone and outlet 0.5%. The gas flow is 13.65 kg mol inlet air per hour. The pure water inlet flow is 45.36 kg mol water per hour. The K'(YA), that is the single mass transfer coefficient in gas, is 3.78 times 10 to the power of -2 kg mol per m³ mole fraction, and the single mass transfer coefficient in liquid equals 6.16 times 10 to the power of -2 kg mol per second m³ mole fraction. The gradient for equilibrium line is 1.18C. So next we have to list out all the information from the question. It will be easy for us to answer the question. Okay, so next we have to draw the diagram for the back absorption column like this. Okay, it contains of two main streams, that is gas stream and liquid stream. For the inlet gas stream, we denoted as V1. For the outlet is V2. For the inlet liquid stream is L2 and outlet is L1. And the composition for the inlet gas stream is Y1, outlet is Y2. Inlet composition for liquid stream is X2 and outlet is X1. And then we fill in the blank from the information given from the question. Okay, so this is the information given from the question, that is the cross-sectional area, temperature, pressure, K'(YA), K'(XA), and this system is operate in dilute solution. So liquid inlet equal to liquid outlet. So L1 equal to L2 equal to L prime equal 45.36 kg mol per hour. It's stated in the question that its gradient for equilibrium line is 1.186. So M equal 1.186, and the linear relation to find the equilibrium line is YA equal to 1.186 XA. So we just have to find 2 points to construct the equilibrium line, YA and XA. For the first point, I use 0, so the XA also got 0, and the second point I use 0.03 as a point for YA, and XA I got 0.0253. Okay, so back to this diagram. So the inlet composition for gas stream is Y1 equal to 0.026 and the outlet is Y2 equal to 0.005. We can get these two from the question given. And the inlet composition for the liquid stream is that is X2 is equal to 0 because it is pure solvent. So we have to find the outlet composition for liquid stream, that is X1. Okay, so in order to get X1, we have to use overall material balance. This equation we can get from the appendix. This equation is used for the back absorption column. So what we just have to substitute all the information such like L prime, X2, V prime, Y1, L prime, X1 we want to find, V prime and Y2. Substitute all the information that we got to this equation, and we will get X1 equal 0.006479. Okay, so we look back at the diagram. So just now we just got the value for X1, that is 0.006479. Actually, this question we have to construct a graph, and in the graph we have to construct an operating line. So with the compositions x1, y1, y2 and x2 can be the point to construct the operating line. Okay, so in order to develop the operating line, the point 1 and the point 2 that we got from the diagram just now, the point 1, so this is the coordinate of point 1, that is x1 is 0.0064789, y1 is 0.026, and point 2, the coordinate is x2 equal to 0, y2 equal to 0.005. Okay, so this is the graph. First step is draw the x-axis and y-axis. Second step is draw the equilibrium line. Construct the equilibrium line by using the coordinate that we got just now. Third step is construct the operating line by using 2 points that we've got just now. The fourth step is just now we have calculated the y-intercept. So the y-intercept, that is c, equals 0.0364. So from the y-intercept here, we just draw the line towards the operating line and also towards the equilibrium line. Okay, so after we construct these three line, that is equilibrium line, operating line and also the y-interception line, so we got 2 points of interception here. First here and second here. So from the first intersection point, that is the intercept for operating line and also y-intercept line, we can get y1 star. Y1 star from the intercept here. What we can do is we just draw the dashed line towards the equilibrium line and continue to draw it horizontally towards the y-axis, and we will get y1 star equal 0.0072. For the second intersection point, that is the intersection between equilibrium line and y-intercept line, we can draw horizontally towards the y-axis to get yi1 and draw the dashed line vertically towards the x-axis to get xi1. So from the graph just now, we just got xi1 equals 0.0134, yi1 equals 0.015 and y1 star equals 0.0072. So the xi1 and yi1, we will use it inside the equation for the original equation to find the slope for back absorption column after this. Okay, so next we want to find PM1 for the second trial. This is to make sure the slope is accurate enough. So the original equation to find slope for back absorption column is this. Okay, so the only difference from the equation just now is 1 minus xim and 1 minus yim. So first of all, in order to find these two, we have to find from this equation 1 minus yim and 1 minus xim. These two equations also we can get from the appendix. Just substitute all the information from the graph and we will get 1 minus yim equals 0.979 and 1 minus xim equals 0.9901. And after that, substitute all the information given to this equation and we will get PM1 equal negative 1.61. So since PM1 and PM1 second trial and PM1 trial 1 has no big difference, so the slope is accurate enough. Next, we want to find the second slope by using the first slope, which is negative 1.6 at point 2 with the coordinate 0, 0.005. So we just use this linear equation y equal mx plus c to calculate the y-intercept. Just substitute the y, m, and x and we will find c equals 0.005. And then when y equal to 0, x equal to 0.003. So the second slope lie on coordinate 0.030. Okay, from the graph, the method is same like like we do just now. So the second slope is this line. This line is the second slope. So it intersect with, there are two intersection point. That is, first is this operating line intersect with the y-intercept line for the second point, and the y-intercept line intersect with the equilibrium line for the second intersection. So with these two intersection point, we can find y2 star, yi2 and xi2. First of all, to find the y2 star, from the first intersection point, we just vertically draw the line, and we got y2 star is equal to 0. And for the yi2 and xi2, we can get from the second intersection point, which is we draw the horizontal line towards the y-axis, and we get yi2, and vertical line to the x-axis, and we get xi2. From the graph, we get xi2 equal to 0.0018, yi2 equal to 0.002, and y2 star equal to 0. Okay, so next is we have to solve for xi minus xm and also y minus yin. These two is used to calculate the equation for A and also for B. Okay, so we just have to substitute the value of xi1, x1, xi2, x2 inside this equation, and we will get the answer is 0.003803. Y minus yin also the same. We just substitute the value of y1, yi1, y2 and yi2 inside this equation, and we will get the answer is 0.006157. Next, we have to calculate the V average and also the L average, because it will be used to solve the question A and also question B. Okay, first of all, in order to get V average, we have to find V1 and V2. So for V1 and V2, this is the equation. For V prime, we just use 13.65 divide by 3600. Why we divide by 3600? Because the unit must be kilogram mole per second. The unit for 13.65 given in the equation is kilogram mole per hour. So we have to divide by 3600 second to get this unit. So V1 we will get 0.00389, and V2 we will get 0.00381. So V average, by using this equation, we will get 0.00385 kilogram mole per second. For the L average, this system is liquid inlet equal to liquid outlet. So the value of L average and L1, L2 and L prime is the same, which is 45.36 kilogram mole per hour. But we want this unit, so we have to divide with 3600. So the answer is 0.0126 kilogram mole per second. So after all the information that we have solved just now, we can solve the question for A, B and C. So for question A, calculate high tower using K prime YA. So the equation that we use is V average over S, y1 minus y2 equal K prime YA Z. Z is what we want to calculate, and 1 minus YIM. All the value of V average as y1 minus y2, K prime YA and y minus YIM have been calculated just now. So we just arrange back the equation, and then we will get Z equal 1.868 meter after we substitute all the information inside this equation. So this is the answer for A. Okay, next we want to calculate the high tower using K prime XA. So this is the equation to calculate the high tower using K prime XA. That is L average over S, x1 minus x2 equal to K prime XA Z, Z that we want to calculate, xi minus xn. So we arrange back the equation like this, and just substitute all the information that we've got just now, and the final answer for Z is equal 1.873 meter. Okay, so for the last question, we have to calculate tower height using capital K prime YA. In order to find the K prime YA, we use this equation that we got from the appendix for pack absorption column. So for this equation, all the values such as K prime YA, K prime XA and M prime we can get it from the equation given. 1 minus y im and 1 minus x im we have calculated just now. So we only have to calculate for the value of 1 minus star m. In order to calculate 1 minus y star m, we use this equation. Substitute the value of y1 star and also y1, and we will get 1 minus y star m equals 0.983. After that, we just substitute all the value inside this equation, and we will get the value of K prime YA is equal to 0.02186. Okay, so next, we use this equation to find Z. V average over S, y1 minus y2 is equal to K prime YA, Z, y minus y star m. So we have to find y minus y star m by using this equation. This equation we can find from the appendix at the pack absorption column section. So we just substitute the value of y1, y1 star, y2, y2 star inside this equation, and we will get the value of 1 minus y star m is equal to 0.0104. So we substitute all the value given inside this equation. We have to arrange this equation and substitute all the value, and we will get Z equal to 1.91 meter. Okay guys, so this is the end of the solution for the case study of the pack absorption column. I hope that you guys will understand and enjoy my video. Thank you for watching.